In my last video, I went over VMs, and in this one we're going to be talking about application services. But before that, I wanted to mention that instead of going through labs, and right now, I'm either going to do one of two things. I'm going to upload them in the final review video, and make sure that I include timestamps so that you can easily find them. I'm going to make an entirely separate video where all I do is go through those labs. I'm going to do them myself unless I can find another lab resource that allows me to do the labs in a more set up environment. But that's not what we're going to be focusing on right now. What we're going to focus on now is application services. But before we do that, we need to understand VMs. So you have your server, and then on the top of the server you have your hypervisor, and then on this hypervisor then you can put on your VMs. And in the VMs, they'll all have their own OS, runtime, applications, data, etc. However, when you look at this can be really slow because it takes minutes to start these up. So, what Azure and a lot of other cloud platforms have is things called containers. Because this is not only slow, it can be a little more expensive and requires a lot of management. And there's some things that you can just patch or fix, and others you can just replace. So if it doesn't have any data or any state, you can just delete it and start it from scratch. So this is great for understanding VMs. And how they work a little more. But for the purposes of this, we're just going to have our box, and it has a CPU, RAM, a solid state or hard drive, and its network. And if you have a VM in your box, it's going to use a portion of these resources. So you virtualize the hardware, and then you add it to the VM. So you could have two, and they'd both be using part of your resources. This is really only for VMs, though. So keep that in mind as we continue. However, you do have to add the applications and the OS onto the VMs in this form. So this is where containers jump in to help virtualize it even more. So you'll have your sandbox, you'll have your kernels, but then you'll also have your containers. And these containers can't see each other. They're separated. And these containers will use images that are on the kernels. In this model, you can only use whatever. So, if this is Linux, you can only use Linux on all three. If this is Windows, you can only use Windows on all three. And typically, you also... I got ahead of myself, sorry. Everything on this, it's just gonna have like read permissions. So you can add read and write to them, but by default. And to do this, you typically create a registry, and Azure uses Azure Container Registry. So if you take the app layer and put it onto an Azure Container Registry, it's always going to be the same thing. you have layers, they're all contained. You simply just need to pull the image and put it onto the registry. So you have, it's kind of like a little tree branch. So you have your main layer, then you can go down another layer, then you have another layer. And let's say you have another container that sprouts out over here. And then like you have like an application or something. Oop, I don't know why that zoomed in. Alright, over. So these will, so when you pull them over and you load them onto it, they'll, they can be pretty powerful. Because you have an OS-based layer, and then on top of that OS, you have your runtime and all that other fun stuff. And then on top of that layer, you could have an application. Registry. So when you create a registry, they don't have to be cloud. But obviously Azure would love it if you put them on the cloud. Registries can be public, private, on cloud, or on premises. So it really doesn't matter. It's suggested because it's easiest to do with a registry. And this kind of just pulls them over and puts them into it. And you have to manually do this. We'll talk about some here in a minute that'll help kind of automate the process. And all the layers that we were talking about are the file systems used by the image. And this can be really helpful for one-off tasks. It gets created, it does a task, and then dies. So it has like a shared life cycle. If you use a container on a kernel and want more protection, you can use Hyper-V container. It makes a new kernel and a new container in the same box. It's not a new host, it's just a container with its own kernel. And you can use a different OS than on the main kernel. It's kind of cool. Azure Container Support provides private repositories and allows geo-replication. Make sure to keep this close to your workload though to minimize your latency. And you can automate this to make your container images. Azure Container Instances can be Linux or Windows. The Azure Container Instance Service can be helpful with burst scenarios. So if you have something that you want to kind of like, okay, so we're going over, like in case we go over, we can have like more resources spin up or something. And this, that can be very helpful with that. And then, so back to the automation thing that I was talking about. Azure Kubernetes Service, which I will be referring to from now on as AKS. It helps create more than just one VM or container or anything. It helps with auto-scaling, updates, storage, network, etc. And the concept of this is going to be called orchestration. And Kubernetes has a database that connects to an API server, which is the interface where you can run commands. There's also something called a scheduler, which checks everything, makes sure that it conforms to all the requirements. And then you have something else called controllers. This checks the health of the containers. This is all on the Kubernetes, AKS. And the amazing thing about all this is that it's pretty much free. And the reason I say pretty much is because once you go in a little more, you can incur some costs. AKS manages and keeps everything healthy and removes previous elements of manually checking everything. And we're gonna, I believe, start to get into where some of the services aren't exactly free. And it's something called a kubelet. It connects to the API, and this is where you start to, this is where you start to pay. There is a kernel and runtime, and now containers are created inside of pods, inside of all that. And the pods are inside of all that. And then in a YAML file, I believe that's how that's pronounced, you set all the requirements that you want, and then you can pretty much take that YAML file, and that can just be like kind of like a template. In my overall video, as I said, I'll include a lab creating AKS and containers and all that stuff. So if you want to look on how to actually do it, go ahead and check out my overall video, or if I end up doing a video where I just do labs or something, go check those out. App service plans are web hosting and are PaaS solutions, and were actually the original PaaS solutions. So, and as a PaaS solution, you pay for nodes, but don't get to see everything. So if you remember, there's IaaS solutions, PaaS solutions, and SaaS solutions. This is a PaaS solution, so you're not buying a software, but you're not exactly buying a server. You're you're paying for something that's already kind of set up, but you still have to do a little bit of work for it. And this is great for like small website type stuff. And I might include this in for a lab or something. I might set one up. I'll probably will end up doing that, but yeah. And to use this, you have app service plans and create a plan. Then you create these plans, adding app services, and this applies to all of your plans. Everything is going to scale together as well. I just threw a lot of information out there, so let's kind of go through that. So you're going to have your app service plans, and then you're going to have your actual plan. And then inside the plans, you can put an app on it that'll go to all of them. And then you have event sources and event handlers. So, for example, someone is creating a blob, that's a source. A function is a handler. And these are just, so a function is a handler. And these are just one of quite a few examples. An event grid connects the source to the handlers and filter and retries them against the handlers. And these are all event driven, so if X happens, then Y happens. Logic apps can always be running or an event. Once again, that would be event driven. Typically, if it's always running, or not even typically, if it's always running, it's going to cost you more than just having it go at an event. The Logic App Designer can help you set all that up. Using a pipeline, AKS will help you. AKS will actually help you set up a pipeline from a GitHub repository onto Azure. DevOps is also another important thing that I need to mention. However, I'm making a video on that currently. We'll go into that a little more. And so I'm just going to save that for that video. So make sure you go check that one out. And then there's also something called Helm, which helps you combine YAML files and put them all in one location. It pretty much compresses all your YAML files, and then you can use Helm commands, which it just compresses everything, makes life easier. When you have your Helm commands, you can use AKS to push out those deployments, and it becomes a very streamlined process. So if you just want to do something once, you don't have to worry about AKS, but if you're doing something for a company and you need to deploy multiple at once, you'll typically want to use AKS because it can be very helpful with streamlining deployments, and all that fun stuff. Before I end this one, all of my notes and everything that I have, I'll make sure that I link this in here. But I have my portfolio, and this. So if you see, I have a little summary thing, my certification I'm working on, because I'm currently a student right now, but I'm working on it. And then you can see that I have some resources. I'll add more soon. Then if you click on this little thing right here, it'll actually bring you to a massive document where I keep all of my notes. It's like 64 pages of it. And then I organize all my vlogs, all of my drawings you can find here, and there's some other things. If I recommend that you watch a different video, that's also in there. And then I also am, I did a fundamentals one already, and then you can kind of see what I'm planning on doing. So not only am I going to do this, I'm also going to move on and to do AWS stuff, Google Cloud stuff, Cisco stuff, and I'm planning on doing this in the same style because I found this very beneficial for me. I feel like if I understand something enough to teach somebody else, then I understand it enough to be confident with it. And that's kind of what I'm looking for going into this AZ-104 exam. Yeah, so you can see all my stuff. It's my portfolio as well, so you'll have just my typical homepage, business card, hobbies and stuff, certifications, and then my GoLite computer science page, because that's where I am currently studying. We've done a bunch of cool stuff. Yeah, we went to the Michigan Cyber Summit not too long ago, as of now. Our resumes here, contact me page, all that kind of stuff. So, yeah, so if you want to check out the rest of the course, pretty much a course that I'm working on it right now, you can go ahead and check out these videos, resources, and all that kind of stuff. But for everything else, that's pretty much going to wrap everything up. Thanks for watching if you made it this far. See ya.